a big focus of LangChain 0.1 is making it as easy as possible to use a language model with external tools, whether those be a search engine, a vector store, a calculator, a Python REPL, anything like that. And so in order to make that as easy as possible, and in order to build a really solid foundation for that, we've put a lot of emphasis on output parsing, which is what we call taking the output of an LLM, which is either a string or a chat message, and converting that into a format where it can be used easily in a downstream manner. And so two of the big things that we've added recently, one is a table of all the different output parsers that we support. So the name and whether a few attributes about it, and then a description of when to use it, because we recognize that we do have a lot of different output parsers, and we've accumulated these, the community has added these over time, and so we wanted to add this table that says, when to use it, what it's good for, and a few key attributes. The second thing that we've put a lot of emphasis on is streaming for these output parsers. So streaming, as general, as we mentioned before in a previous video, is really important for us. And streaming can be tricky for output parsing because let's take JSON, for example. If you want to parse something into a JSON blob, into like a dictionary, if you only have half of the output, if you only have half of the string, if you pass that to JSON.loads, then it won't actually load. It will raise an error because only half of it is there. Same with XML, same with other formats. And so we've put a lot of emphasis on basically making it easy and possible to get streaming for things that have output parsers on them. So taking a look really quickly at this notebook that I prepared to walk through some of these examples. First is just a basic, the most basic output parser that we have, which converts a chat message into a string. So strings are more usable than chat messages. A lot of modern models return chat messages, and so we have a really simple utility that just converts it into a string. And so we have this chain. If we call this chain with this input, then we get back, this AI message. Oftentimes we just want the string, so we can add in this stir output parser. If you see these around the docs, that's why we use it in so many places, to convert it into a string that we can use around, because not all applications are chat. The other common output parser that I want to walk through is one that uses OpenAI function calling. So function calling was introduced by OpenAI a while ago as a way to basically return outputs in a structured manner. It's not guaranteed that they'll be in that structured format, but it's pretty likely. And so we've added some output parsers and a bunch of cookbooks to make working with this function calling ability really easy. Other models are starting to add this as well. Some of them are just doing a drop-in replacement for OpenAI, so you can use the exact same output parsers that we have here. Others of them are slightly different, and so we'll add support for those. But at the moment, OpenAI function calling is probably the most reliable way to get structured information back from a language model, and so we've focused on really adding really good support for it. So part of that comes with a nice developer experience as well, and so for that we rely heavily on Pydantic. So Pydantic makes it really easy to define basically schemas for things. So OpenAI function calling relies on JSON schemas being passed in. I don't really like writing JSON schemas by hand. I'd much rather write a Pydantic module and then convert that to a JSON schema. So I can do that by having by using this base model thing from Pydantic. I can then write this class called joke, and I can give it a description. We actually require that all of these things that will convert into JSON schemas have descriptions. And the reason that we do that is because this function calling definition, this joke thing right here, this is actually this goes into the prompt. You should think of this as a prompt. So everything that we write here, from the description of the overall thing to the description of each field, is really prompting the language model. And so we want to make sure that you're writing prompts, so we require that you have it here. For the fields, it's optional, but we also provide it here. We provide some description on basically how to use this. And so from there, we then have a helper function to convert from a Pydantic model to the OpenAI function schema that it requires. And then we have this output, this OpenAI functions parser, which converts it to JSON. So JSON is a really convenient schema to use to pass into downstream things. So we can create this parser. We can then create a chain. And so the chain is this prompt. It's this model, but we also pass in functions. So we pass in this this OpenAI functions list that we have here, and then we pass the result of this. We chain it with this parser, and so if we do this, we can see that it returns a JSON blob with a setup and a punchline. And so to get a little bit more intuition, we can take a look at LangSmith to see what's going on under the hood. If we take a look at LangSmith, we can find the run here. We can go into it. There's one important call, but let's look at all of them just because we want to see exactly what's going on. First is the chat prompt template, basically just formats it into a prompt to the language model. Now let's look at the interesting bit, the OpenAI call. So here we can see that we have this function definition up here. So this is the input, this is the prompt. This is also part of the input, it's the function definition. So if we click here, we can now see a nice description of the function that we pass in. We can see the name of it, the description here, and then the different arguments and their types and their names and the descriptions for those. We can also see the output of this language model call. And this is the raw response from OpenAI. It's got this function call thing. This is the syntax they use with arguments and names. And so we can see what the JSON output function parser is actually doing. And it's taking in this, which is the AI message that's returned from OpenAI, which has no content, but then has this function call thing. And this arguments here is a JSON string, and it's basically parsing it out correctly and returning the setup and the punchline. As mentioned, we've also done a lot of work to support streaming here. So here we can do the same thing. Let's pass in bears as a topic or bars as a topic. And so here we can see that it streams back results. So again, like this is being done by parsing the partially completed JSON string, figuring out which keys are present and then representing those. For all these output parser types, we've also included notebooks on how to use them. So if you click on any one of them, you'll see notebooks and tutorials on how to use them, streaming, some functionality there. We've invested a lot of work in making it easy to structure the responses from language models, because that's a big part of what LangChain does. Some of that is using OpenAI function calling. Other of that doesn't rely on it because a lot of open source models and other models don't have that. And so we have actually the majority of our output parsers don't use function calling at all.